This video deals with the components of our planet and the resulting materials we see all around us. It is about how elements bond together to form minerals and how minerals form the rocks that make up our planet, including the ones we see here in the surface and the ones that we don't see and that are below us underground and even deeper below our thin outer crust of our planet. Enjoy it and don't forget to like, share and subscribe. As a kid, I was fascinated by rocks. Originally, I never thought about why. I just liked the shapes and colors. I never imagined that I would end up being a geologist and that the fascination for rocks would lead me to teach and to make videos about it. After all, I just wanted to have my own rock collection. Now that I reflect back about it, I never thought that the color, the shape, the hardness of a particular rock was dictated at the very atomic level by the atoms and elements that bind together to make the minerals and the minerals that combine together in the rocks. I never thought that all these things that we like about minerals and rocks, from jewelry to our granite countertop in the kitchen, are dictated by the type of elements and the crystalline arrangement. I guess I could not think about that because we cannot see such a tiny particles and crystals that make up the most of the minerals. To see the particles, atoms and elements of the minerals that build up the rocks, we would have to go into an astonishing small scale that requires the most advanced modern analytical techniques. But in some cases, we can. And we don't need this fancy equipment. More importantly, at a larger scale, we can see all these resulting properties that we like with our own eyes, including color, shape, and much more. The result of all the properties of the rocks that are determined by the chemical composition and crystalline structure of the minerals contained within them are everywhere for us to see and to marvel. We just have to take a look. This video deals with the materials that compose the Earth. To begin with, we must remember that from the Big Bang, a wide variety of atoms of many different elements are available and free to bond with each other to form different compounds. An atom consists of a nucleus surrounded by one or more electrons. The simplest atom is that of hydrogen and consists of a single proton orbited by a single electron. However, that is the basic, simplest form. Atoms that are heavier than hydrogen also contain neutrons in their nuclei. Thus, proton, neutrons, and electrons, these three particles from all the atoms of all the elements and isotopes in nature. An element is the set of atoms having the same number of protons in their nuclei. An isotope is the set of atoms having the same number of protons and neutrons in their nuclei. Normally, the number of protons in the nucleus is equal to the number of electrons that surround the nucleus so that the atoms remain neutral in terms of electrostatic charges. This is because both protons and electrons share a fundamental property called electrical charge. The charge of protons and electrons are equal in magnitude but opposite in polarity. So when these two particles are paired, their charges cancel each other out. Since matter typically contains equal numbers of positively charged protons and negatively charged electrons, most substances are electrically neutral. Different isotopes of many different elements occur naturally and are found in the rocks. They are very important in geology as they are used in absolute age dating of the minerals and rocks that contain them. This will be the topic of a future video. At this stage, we must also say that overall we must make two broad distinctions. And that is to say that in nature, solid matter occurs as amorphous solids and crystalline solids. In geology, for the most part, we deal with the solid substances that have a crystalline arrangement. In a broader sense, we call these substances minerals such as diamonds, copper, etc. There are some particular ones that have the same composition, but can have different internal organization. Check for example these diamonds and this graphite. They have the same chemical composition, but have completely opposite properties such as hardness, sitting almost at the end of the hardness spectrum. They are both made of carbon. However, in diamonds, the arrangement is different than in graphite. Diamonds are so hard that we use them in tunneling machines, but graphite is so soft that we use it even for writing. Amazing example, hey? However, we also deal with some structures that do not have a crystalline arrangement, such as flint and opal. Check out this obsidian, for example.
It is made of silica, like quartz, but in a totally disorderly arrangement. Both amorphous and crystalline solids are important because they constitute the basic building blocks of the rocks.
Beyond geology anyways, as humans, we have a long history interacting directly or indirectly with minerals. Humans have used minerals for tool making, ritual, practical building, and decorative purposes for thousands of years. The archaeological record suggests that our relationship with minerals goes far back into prehistory. Among the first minerals that we mined, perhaps the ones that we have the best evidence for were flint and chair, which our ancestors used to build weapons, cutting, and hunting tools. Stuff like axes and many other utensils were fashioned from these materials. Survival records suggest that as early as 3700 BC, Egyptians began mining minerals like gold, silver, and copper to make tools for ritual, building, and decorative purposes. As early as 2200 BC, humans had discovered how to combine copper with tin to make bronze, and a strong, hard alloy. Later, humans developed a process to extract iron from minerals such as hematite, a discovery that marked the decline of the Bronze Age. During the Middle Ages, mining of a variety of minerals became common, and the need for their exploration and exploitation prompted their study and our need as humans for their understanding, paving the way for mineralogy as the modern discipline that is today.
We can conceive minerals as the basic building blocks of the rocks. The term mineral is used in several ways. For example, those concerned with health and fitness refer to the benefits of vitamins and minerals. The mining industry typically uses the word when referring to anything taken out of the ground, such as coal, iron ore, sand, or gravel. So the term has a different meaning depending on the context.
Geologists define a mineral as any naturally occurring inorganic solid that possesses an orderly crystalline structure and a definite chemical composition that allows for some variation. Thus, earth materials that are classified as minerals exhibit the following characteristics. Minerals formed by natural geologic processes. Synthetic materials, meaning those produced in a laboratory or by human intervention, are not considered minerals. Inorganic crystalline solids such as ordinary table salt, halite that are found naturally in the ground are considered minerals. Organic compounds, on the other hand, are generally not. Sugar, a crystalline solid like salt but that comes from sugar cane or sugar beets, is a common example of such an organic compound. Many marine animals secrete inorganic compounds such as calcium carbonate, calcite, in the form of shell sand in coral reefs. If these materials are buried and become part of the rock record, geologists consider them minerals. Only solid crystalline substances are considered minerals. Ice, frozen water, fits this criterion and is considered a mineral, whereas liquid water and water vapor do not. The exception is mercury, which is found in its liquid form in nature. Minerals are crystalline substances, which means their atoms are arranged in an orderly, repetitive manner. This orderly packing of atoms is reflected in the regularly shaped objects called crystals. Some naturally occurring solids, such as volcanic glass, obsidians, lack of a repetitive atomic structure and are not considered minerals. Most minerals are chemical compounds having compositions that can be expressed by a chemical formula. For example, the common mineral quartz has the formula SiO2, which indicates that quartz consists of silicon and oxygen atoms in a ratio of 1:2. This proportion of silicon to oxygen is true for any sample of pure quartz, regardless of its origin. However, the compositions of some minerals vary within specific, well-defined limits. This occurs because certain elements can substitute for others of similar size without changing the mineral's internal structure. However, if minerals are the building blocks of the rocks, how can we define rocks? Well, rocks are a little bit more loosely defined. Simply, a rock is any solid mass of mineral, all mineral-like matter that similarly to minerals are found in nature as part of our planet.
For example, let's check this rock that we can use to illustrate something that occurs in most of the rocks to make them rocks. This sample of granite shows how the rocks in nature are built. They normally occur as aggregate of several different minerals. This granite is perfect to illustrate this fact as the main component minerals display different colors and shapes. It is composed of quartz, feldspar, and mica. 3 different minerals, each one with a different set of crystallographic arrangement and composition, consequently a different set of physical properties.
When we refer to the fact that rocks occur as an aggregate of minerals, the term aggregate implies that the minerals are joined in such a way that their individual properties are retained. Note that the mineral constituent of granite can be easily identified as we have a close-up view to the sample. We can even identify with our naked eye or with a magnifying glass the different component minerals. This video video deals primarily with the nature of minerals. Keep in mind that most rocks are simply aggregates of minerals. All these things that we love about the minerals, such as shape, color, the feel of them, the smoothness, the hardness, and the properties of the rocks they form when they come together, are largely the result of each mineral chemical composition and crystalline structure. It is amazing how these little tiny particles that we cannot see and how they are organized are the one thing responsible for the stuff we like about both minerals and rocks. So, to start off to understand our planet, we must first consider these Earth's basic building block materials. Well, to understand what the Earth is made of. This way, we can build our understanding that allowed us to take a closer look at Earth's three major rock groups: igneous, sedimentary, and metamorphic rocks. However, they will be the subject of a later video. Thank you for watching up to this point. I hope this video contributes to increase your admiration and amazement towards our planet. Please let me know in the comment box which one you think is the most beautiful mineral found in our planet, or at least your favorite one. And more importantly, why? About myself, I do like a mineral called lapis lazuli. Why? Because number one, blue is my favorite color, and number two, I also like how the old masters, the old painters, used it in their paintings. I think it's just beautiful. And you? Please let me know in the comment box and I will do my best to answer all your comments. Don't forget to like, share, and subscribe, and I will see you in our next video. Ciao!